Okay, let's dive into this. If you look really closely at our modern digital world, running silently behind the scenes of just about everything, from those massive enterprise web applications to the Android phone sitting in your pocket, you are going to find Java. It is quite literally the invisible backbone of our tech-driven lives. Today, in this explainer, we're going on a journey together. I'm going to take you from absolute zero, whether you have never typed a single line of code in your life or you're just looking to solidify your foundation, to actually writing and understanding your very own Java code.
Think of this as a structured masterclass to help lower that intimidation factor and build some instant confidence. Here is our roadmap. We'll start with a welcome to the language itself, demystify how Java actually works, and unpack the essential building blocks. After that, we'll dive in and write your first program, cover some common beginner mistakes to watch out for, and finally map out your next steps.
So, let's kick things off with Section 1, Welcome to Java.
To really understand why this language is so monumental, we need to take a quick trip back in time. The year is 1995. A brilliant developer named James Gosling, working over at Sun Microsystems, releases Java into the world. Now, get this, it was originally designed for interactive television, but it quickly pivoted and it became the absolute backbone of the early internet era. And what's really fascinating here is the game-changing philosophy Gosling instilled: write once, run anywhere, or WORA. You see, before Java, you often had to rewrite your code completely if you wanted it to run on a Windows machine versus a Mac or a Linux server. Java was a total game changer because it promised that your compiled code could run on absolutely any device, regardless of the underlying hardware.
Moving right along to Section 2, How Java Actually Works.
To understand how that write once, run anywhere magic actually happens, we have to demystify the alphabet soup of the Java ecosystem. You are going to hear these three acronyms a lot, so let's use a clear analogy. First up, we have the JDK, the Java Development Kit. Think of this as your master toolkit. It's a software you install to actually write and compile your source code. Next is the JRE, the Java Runtime Environment. This provides the standard libraries and the environment itself. It's basically the stage where your program performs. Finally, we have the JVM, the Java Virtual Machine. This is the engine. It's the piece of software that actually interprets and executes your bytecode on whatever platform you happen to be using. Together, this trio is exactly what makes Java completely platform independent.
Which brings us to Section 3, the essential building blocks.
Okay, before we look at any actual code, we absolutely need to understand the fundamental rules of Java's system. Java is what we call a statically typed language. That just means every single variable you create has to be declared with a specific data type before you can even use it. The system demands to know exactly what kind of data it's handling. We've got two main categories here. On one side, we have primitive data types. These are the built-in raw values held directly in memory, things like int for integers, double for decimals, and boolean for a simple true or false. On the other side, we have non-primitive or reference types, like string for text and arrays for collections. If you're a beginner, don't get overwhelmed. Just focus primarily on these five for now: int, double, char, boolean, and string. Master those, and you've got the keys to the kingdom.
Beyond just data types, Java was engineered with some incredibly powerful design principles. It's fully object-oriented, which promotes a really clean, reusable code design. It handles complex multi-threading right out of the box, and it's notoriously secure. So the crucial point is this feature right here: automatic memory management. In a lot of older languages, you had to manually allocate and free up computer memory. It was a nightmare, and honestly, it led to a ton of crashes. But Java introduced a built-in garbage collector. It acts as an automatic background cleaner, deallocating unused memory and preventing memory leaks without you having to lift a single finger.
Let's move on to Section 4, Writing Your First Program.
Now we're transitioning from the theoretical building blocks to the practical, actionable stuff. And here's a secret. No matter how massive a Java application is, every single program follows this exact, universal three-step rhythm. Step 1, you write. You create a text file, let's call it helloworld.java, and you type out your code. Step 2, you compile. You open up your terminal and you tell the JDK to compile it by typing java k helloworld.java. This simply translates your human-readable code into bytecode. And finally, step 3, you run. You type java hello world, and the JVM takes over, executing that bytecode and displaying your creation on the screen. Write, compile, run. It becomes a deeply satisfying cycle.
Let me give you a quick guided tour of what that code actually looks like in practice. Here is the classic Hello World program, slightly adapted as a welcome message. Right at the top, you'll see public class welcome. That is your class declaration, and remember, everything in Java lives inside a class. Inside of that, you see public static void main string args. Now, don't let that syntax scare you. That is simply the main method. Think of it as the front door. It is the entry point where the JVM starts reading your program. And right inside that door, we have our action, system.out.println, which simply tells the computer to print our welcome text to the screen.
Once you understand that basic structure, you can start building out some simple logic. This is how we level up. We can add variables to do basic math, like adding 10 and 20. We can use if-else conditions to check if a number is even or odd. And this brilliantly illustrates the real power of loops. Looking at a simple for loop, with just 3 lines of code, we can instruct the computer to print the numbers 1 through 10, iterating over and over. You see, you're no longer just typing text anymore. You are now commanding the machine's logic.
Section 5. Avoiding common beginner mistakes.
Now, before you run off to build the next big app, I want you to know that every single developer faces these errors. It is a total rite of passage. So, let's do a rapid-fire rundown to save you hours of debugging frustration. First, missing semicolons. Every single statement in Java must end with a semicolon, period. If you forget it, the compiler will absolutely yell at you. Second, case sensitivity. Java is incredibly strict here. A capital S system and a lowercase s system are completely different things to Java. Third, your public class name must exactly match your file name. If your class is called hello, your file must be hello.java. And finally, type mismatches. You can't just shove a decimal value into an integer variable without the compiler throwing a fit. So always be mindful of your types.
Which brings us to our final section, Section 6, your next programming steps.
You've got the basics down. So what are your next steps in this massive digital ecosystem? Well, what is so exciting here is that the fundamental building blocks you just learned in this explainer are the exact same keys you need to unlock incredibly diverse career paths. Core Java sits at the center of all of this. Whether you want to build Android mobile apps, scale up enterprise web applications, dive into cloud and microservices, or crunch massive numbers in big data with Hadoop, Java gives you a clear pathway to all of those domains. You aren't just learning a new language, you're getting access to an entire industry.
But to continue your journey, you need the right tools. I highly recommend picking up Head First Java by Kathy Sierra and Bert Bates. It has this uniquely visual, highly engaging style that makes complex object-oriented concepts incredibly beginner-friendly and super memorable. Then, as you get more advanced, Core Java Volume 1 and Joshua Bloch's Effective Java are absolute gold standards in the industry. And of course, always lean on the official documentation at docs.oracle.com.
As you dive into those resources, I want to challenge you to truly adopt a programmer's mindset. Great developers don't just memorize syntax, right? They think creatively, and they plan out their logic before they ever touch the keyboard. So, try some out-of-the-box puzzles. Can you figure out how to swap 2 integers without using a temporary third variable? Or maybe try building a recursive Fibonacci sequence. Sketch out your logic, draw some flowcharts, and reason through the problem first. We'll leave it there with this brilliant quote from Mark Twain. The secret to getting ahead is getting started. In Java, the absolute best way to learn is to write code every single day. Even just 30 minutes of practice today will make a massive difference in your journey. You have the blueprint, you have the tools, and you understand the rhythm. The only provocative question left is, what are you going to build first?